Hello, my amazing Algebra Half students. This is Mrs. A, and I love math. And today we're doing Lesson 97, Edition 2, and 95, Edition 3 in your Saxon Blue Book. And we're talking about variables on both sides of the equation. So what we have to do is we don't want our variables on two sides of the equation because we're trying to solve for the variable. We have a 3x plus 3 equals x minus 5. And I'm supposed to try to get x by itself. And how can I get x by itself when it's here and here? It's hard. So what we're going to do is get the x on one side. That's going to be our first step, is getting the x on one side. So in the first problem, we're going to, because they're exactly the same, aren't we? We're going to move this x over here. The way we're going to do that is we're going to subtract an x and subtract an x on the other side. When we do that, we have a 3x minus an x gives me a 2x plus 3 equals negative 5. Okay, so now we're used to seeing problems that are like this. So now what do? We're trying to get our x by itself, so we need to get rid of the 3. So we would minus the 3 and minus the 3 over here. That's going to go away. And we're going to get 2x equals, and then we have negative 5, take away another 3 is a negative 8. That means that x, divide by 2, x is a negative 4. Okay, so we did the problem this way, and we got an x is a negative 4. Now we can check that, and we should check that, by plugging in our negative 4 into the original equation. So let's try it. Now we've got two places to plug it in. So let's make this x a negative 4, and let's make this x a negative 4, and let's see if the two sides equal each other. On this side, we have multiplication has to happen first. Negative 12 plus 3 is a negative 9. And then on the other side, we have a negative 4 minus 5 is also a negative 9. And it checks. So x is equal to negative 4 is the correct answer to the problem. Remember, we should always be able to plug it back in and have it work. So now we're going to do this one. It's the same problem, but we're going to get the 3x over this way. Just see if we get the same answer. So we're going to subtract the 3x and subtract the 3x on this side. Okay, so now this goes away, and we end up with 3 equals. So that's the 3 here. I ran out of space. X plus a negative 3x is a negative 2x minus 5. Now we're trying to get this by itself, so shouldn't we send the 5 on the other direction? So plus 5, plus 5. And now what do I get? Negative 2x equals 8. All right, now look what we have here. So I'm going to erase this because we already have that answer up there. So now we're going to put this one. 8 equals negative 2x. And that's gone. Now look what we had before. Before we had 2x is negative 8. And now we have 8 is negative 2x. Okay, so the sides have flipped and changed signs, but they have the same solution, don't they? If I divide this side by negative 2 and I divide this side by negative 2, guess what I have? X equals negative 4. So I did it both ways to show you it really doesn't matter. Now it may be a little bit easier if you go for getting a positive x. So like if I subtract the x from both sides, then I still have a positive x. I have a positive 2x here. All right. When I did it the other way, I wound up with a negative 2x, which is still correct. It just may not be quite as easy for you. A lot of students like to go for the positive x, and that's fine because it really doesn't matter which way you subtract it, as long as you get all your x's in one place. So let's do some practice problems. Okay, we're going to do a couple more examples before we do practices, all right? So here we have a 4x on one side, and we have a 2x on the other. So we want to get all of our x's on one side. So I'm going to subtract the 2x from both sides, because that will still leave me a positive on the x term. So 4x plus a negative 2x is a 2x plus 2 equals, cancel that out, plus 5. Okay? So now I want to get the x by itself, so I'm going to get rid of the negative 2. Negative 2, negative 2. Remember, always like terms get added together. 2x, this cancels, equals 5 plus a negative 2 is 3. So now we're going to divide by 2, and x equals 3/2. Okay, so now let's go back and check. If I plug in a 3/2 here, let's go with a different color. So here I'm going to plug in 3/2, and over here I'm going to plug in to the original equation a 3/2. To write it real small because I don't have much room up there. Okay, so now we're going to multiply. Okay, now 4 is on the top, right? 4 times 3/2. The 4 is on the top, so it will cancel with the 2, and it will leave me with a 6. So on the left, I have 6 plus 2 is 8. So 8 on the left. And now I do the same thing over here. The 2 is in the numerator, and the 2 will cancel the 2, leaving a 3 plus 5 is 8, and it checks. Okay, so there's your first example. Let's go on for example number 2. This is example number 2, and we have an x and an x over there. So how about if we add, well, you know what? I think I'm going to do this one the other way. Simply because if I take away that x, if I get rid of it, I'll have 0 on that side. So let's get rid of this x because we already have something else over there. It would work both ways. So minus 4x minus 4x. Okay, so now when I do the math, this is going to cancel, isn't it? And I'm going to get negative 2 equals negative 1x minus 4x is negative 5x. So I'm going to divide by what? I'm trying to get the x by itself, so let's divide by the negative 5 and the negative 5 on the other side, and I get positive 2/5. When I divide a negative by a negative, equals x, because those cancel. Now, I don't like my x on the right. It looks weird to me, so I will move it over to that side. Easy as that. X is 2/5. Now, we should check. Is x equal 2/5? So when we plug it back in, and I have room on the board to plug it in, 4 times x, and x is 2/5, minus 2 is negative 2/5. Okay, so that would be our check. Let's see if it's right. So 4 times 2/5 is 8/5. Minus 2 is negative 2/5. Okay, now this is where getting a common denominator makes things easier. So instead of 2, could I write 10/5? Because isn't 10/5 the same as 2? It is, isn't it? So I'm going to take away the 2, and I'm going to write minus 10/5. And since they all have 5, then 8 take away 10 is negative 2, and it works. There is your last example. And now we're going to do some practices. Here is your first practice. So I want you to copy it down and then pause your video. Try to do it by yourself first. Okay, hopefully you did that. So now what I'm going to do is I'm going to choose to move my x over there because this will still be positive. So I'm going to add a 4x to get rid of the negative 4x, and I'm going to add the same thing on the other side. These cancel, and I get a 3. On the other side, I have a 7x plus a 4x is 11x minus 8. Now, I'm going to have to get rid of the 8 because I want my 11x by itself, so add 8, and I get 11. Boy, that's convenient. 11 is 11x. This cancels out. So when I divide by 11 to get my x by itself, then I get x equals 1. So shouldn't we check it? If we plug in a 1 back into the original equation, we have negative 4 times 1 is negative 4 plus 3 equals 7 times 1, which is 7 minus 8. This is a negative 1 on this side. This is a negative 1 on this side. And negative 1 does equal negative 1. So there's all the work that you should have on your board or your paper. This is the last problem that we have to practice on, and then we'll be done with this lesson. So copy it down and pause your video. Hopefully you did that. All right, so now we're going to move it either direction. I'm going to go ahead and move it this way because I want to show you one more time getting a negative x is no problem. So we're going to subtract a 6x, and we're going to subtract a 6x. 2x minus 6x is negative 4x. Minus the 5. This goes away, and we get a 4. Now we're trying to get the x. We only have one x now. Trying to get the x by itself, we need to get rid of the negative 5, so we add a 5. And we add a 5 over here. This cancels out. We get negative 4x equals 9. Now we're trying to get x by itself, so we're going to have to divide by a negative 4, divide by a negative 4, which is not really a problem because we know that a positive divided by a negative is a negative. Our answer is negative 9/4, and that should be our x. But let's check it, okay? So let's go up here and let's plug in a negative 9/4 and right here, a negative 9/4. And let's check to make sure that our answer is good. 2 times the negative 9/4. Remember, the 2 is in the numerator, so the 2 and the 4 will cancel, but leaving a 2 in the denominator. So that's going to become a negative 9/2 minus the 5. How could we write the 5 with a 2 in the denominator? If we just put a 1 and we multiply by 2 over 2, don't we get minus 10 over 2? And that's easier to think about. I'm going to erase some of this here so that we have room for our check. Oops, almost erased my answer. And then equals 6 times negative 9/4. Now the 6 on the top and the 4 on the bottom will cancel with a 2, cancel a 2 out of each. So we're going to wind up with 18, no, let's just do the whole thing because, all right, so that's going to be a 9/4 and a 6 over 1. This cancels with this, 2, 3, 27 over 2, and it's going to be negative. So let's write that down. Negative 27 over 2 plus 4. But if we write 4 over 1, we multiply 2 over 2, then we can get 8 over 2. Let's see if it's right. Those are both over 2, so we can add them together, get negative 19 over 2. Okay, and then we add these together. Since they're opposite signs, we really subtract, and we get negative 19 over 2 on that side also. And guess what? Negative 19 over 2 equals negative 19 over 2. So the solution really was negative 9/4. And that is your last practice. And we are done with lesson 97. And this is Mrs. A. And may God bless your day.